In this section, we are going to talk about tokens, the AI tokens. And everybody knows AI service provider, they charge you based on the number of tokens you are going to use. So on the left hand side, you can see if my input is I love networking, that is getting tokenized. And there are 3 tokens are generated with this text or the prompt. How it is happening? This is my input example, and this gets breaks into 3 tokens. So the total text is getting tokenized because computer do not understand the text. Hence you need to do a kind of the mapping, which is called token. And every single word or some characters or some text, they are going to have those tokens. So this will get into 3 tokens. These 3 tokens are sent to AI model, which you see in the middle. Since the AI processes only a few tokens, it performs less computation, uses less GPU time, and therefore cost is also less. So fewer tokens means lower the cost. Now look at the right hand side, and this is going to be the example input. So instead of one short sentence, we have a long paragraph, which you can put as a prompt. The tokenizer breaks it into small tokens. So these are the tokens basically, and there are many. Even single token has to pass through every layer of a neural network, just like the features. The more tokens the model processes, the more GPU, computation, memory, electricity, and time it is going to consume. Since AI provider pay for these computing resource, they charge users based on the number of token processed. That is why more tokens means more cost or the higher cost for you. And the total cost is going to be what is your input token plus your output token. This means you are charged not only for the tokens you send to AI, but also for the tokens the AI going to generate in terms of the response. So remember this key point. AI providers don't charge by the number of birds, they charge by the number of token processed. Finally, this is why efficient tokenizer are so valuable. If a tokenizer can represent the same sentence with fewer tokens, the AI performs less computation, respond faster, and costs less to run. Let's try to understand with another example. Let's say this is the prompt by the user, explain artificial intelligence. This is getting tokenized and the number of tokens are 4. These tokens will be processed by your LLM model. An LLM is going to generate a set of tokens. Those are called the output token IDs, and these output token IDs will be further decoding. So earlier on the input, we were doing text to token conversion. Now the output is token. So you need to convert it again to the human readable format, which is going to be decoding. So now these tokens, you need to decode it. And when you are going to decode it, your answer is going to be like this: artificial intelligence is a field of study. So this is going to be the whole process basically. You can see at the top, basically you can enter some sort of the text. Then the tokenizer is going to split text into the tokens and look up for each tokens in its vocabulary, which is simply a lookup table stored in the tokenizer file. Each token has a unique token ID. These IDs are sent to LLM, which processes only numbers and generate the new token IDs. Finally, Tokenizer converts these new generated tokens to text. The bottom section shows a tokenizer file, and different tokenizer, they are going to have a different format as well. So if you talk about VPE tokenizer, which is used for the GPT-2, they are going to use a file like vocab.json and merge.txt. Similarly, if you are going to go for sentence piece tokenizer like Llama, Mistral, they use a single tokenizer model files that contains vocabulary, token mapping, merge rule, and special tokens as well. So the file format may differ for different tokenizers, but what they are doing, they have is sort of the mapping. So think like they created a database, and that database has this kind of text to token ID mapping. And whenever a input comes, they are going to do the lookup and do the mapping. So you can say a tokenizer files, they are going to act like the dictionary or the lookup table that maps every token to a unique number. The LLM never reads word directly. It only processes these token IDs. Does that really mean that I can use the Oxford Dictionary and create a mapping? Because the Oxford Dictionary is designed for the humans. It contains complete word and their meanings, but that's not true. We cannot do it. What we are doing, a AI tokenizer has a different goal altogether. It needs to represent text as efficiently as possible. So what we are going to do, if we stored every word separately, word like networking, internationalization, unbelievable, would each need their own entry. This would create and, or I would say it will create huge vocabulary, and that is going to be inefficient. It still couldn't handle the new or made up words. So AI tokenizer, they will only store whole words and reusable words and reusable word parts. For example, if I say networking, it get split into network and ing. That is easy to find. Similarly, this one I can split into international and ization. If you split unbelievable, unbelievable. This approach makes the vocabulary much smaller and more flexible. It also allows AI to process multiple language, punctuation, emojis, codes, numbers, and even word it has never seen before by combining existing tokens. So the goal of the tokenizer is not to store every word, it is to represent any text efficiently using a compact set of reusable tokens. Let's talk about GPT-2 tokenizer and do not pay attention right hand side, just pay attention to this value, which is called vocabulary size. And if you see, this is how it is going to look like. You have these kind of the token mappings and the total unique token it is saying 50,257. Let's verify it and rest of the matter we are going to talk in the upcoming slides. This is the screenshot I have taken from the Colab where I did the lab. What I wanted to show you, this is my code. On the top and this code is basically going to return you the value of the vocabulary size. So what it is using is importing auto tokenizer from pre-trained GPT-2, and then we are going to print the size of the vocabulary, basically the last line. It's exactly matching the claim I had made on the previous slide that the vocabulary size for the GPT-2 is going to be 50,257. That means that file will have these many text or symbols to token ID mapping. This is another screenshot, and what I'm doing here, just printing first 20 token IDs. So you can see 0 to 19, and this is how the mapping will look like inside the vocabulary. Just to prove not all the vocabularies are going to be same in the size, I have taken two down. One is GPT-2 and the Quinn, and the results are here. The GPT-2 is going to have 50,257 entries. However, Quinn is going to be bit larger. If my text or the prompt is I love networking, you can use this code and see how many tokens it is going to return. So when you run this code, the token count is 3. What it means? It is getting splitted into the 3 tokens. So one token is for I, another token is for the love, and the third token is for the networking. So technically 3 tokens out of this prompt. If you do the same exercise with another tokenizer with Quinn, what is happening? It is also returning a total count of 3. So they are equally efficient. Now I'm going to put this as a text, which these tokenizer never has seen before. Here you can basically test the actual efficiency of these tokenizer. So going with GPT-4o, this is the output, and this is how it is going to split. So the total count is 8, and you can see these tokens are generated based on these kind of the text. Similar thing, similar text, if you pass it to Quen, what it is saying, I'm going to consume 9 tokens. So obviously 8 tokens, this is going to be efficient than the Quen. And you can also see how these texts are getting mapped. It is also different from tokenizer to tokenizer. Whatever the input text we are going to put in the prompt, it is going to do some lookup. So there can be multiple situations, and let's try to understand with multiple situations. So the situation number 1 or the example number 1, whatever the word we are putting into the prompt, that word exists in the vocabulary. So what will happen? This is input, and it tells, yes, I do exist. So this is going to be the direct mapping. The networking will get mapped to this ID, and this is going to be your output token. Let's talk about another example where the word does not exist in the vocabulary. So I'm going to put input as a network automation. Does it exist? Technically not. So what it is going to do, it is going to try to match the longest possible token. But it found I do have network, I do have a automation, so output is going to be 2 tokens, and those 2 tokens are going to be 21,500 and 4,521. That is how it is going to do the lookup. Let's test it with the Hindi word namaste, and when you are going to do it with the GPT-4o, the tokenizer is saying this get converted into 4 tokens, and these are going to be the token IDs. However, if you do the same thing with the Queen, it is going to generate 6 tokens. So in terms of this word, this is GPT-4o is going to be more efficient. Let's talk about byte pair encoding that basically builds the tokenizer vocabulary. So how to start? Initially, the tokenizer knows only the individual character. It is going to scan this entire data set. And why I'm saying the entire data set, just like training the LLM, you need to train your tokenizer as well. These two trainings are going to be very, very different. And then while you are training it, it finds the most frequent pair of adjacent token, merge them into the new token. This process repeats again and again, creating large subwords like NE, NET, NETWOR, and finally the network. The vocabulary keeps growing until it reaches to the desired size, such as 50,000 tokens. So stage 0, where you see the tokenizer creates the new token, NE adds to the vocabulary. It replaces every occurrence of N and E with NE throughout the dataset. And then the second merge happen, the third merge happen, and the process goes on. This is one slide. You can access this tokenizer playground from your browser. And what I'm just going to tell you here, there are different models available. They are going to use a different type of tokenizer. So if I'm going to use the same word with different tokenizers, you can see the difference, who is more efficient for a particular language or maybe for a particular word. So for Namaste, this gives me 6 token. GPT-3 gives me 12. Llama gives me 5. And Claude is also going to give me the token 6. Similarly, you can check for a particular prompt how these tokenizers are going to behave. Thank you for watching, and I will see you in the next episode.